This is what we were doing last time. It was Venn diagrams. So given sets, we were basically creating visual representations of what a set is. Okay. So we did that. I think the last thing we did was the Mexican food and Chinese food. I don't know if you guys were there or watched the video. That was the last example we did. So let's do example 5. So this time they're giving us the actual Venn diagram. Venn is just some guy's name, who cares? So here they have a set A, which is this circle, a set B, which is this circle, and then they ask you what is inside the following sets. So they ask you, okay, what's in A, right? So I'll go ahead and draw this picture just so it's a little bit. We don't have to keep switching back and forth. My picture won't be as pretty though. So the 6, 7, 9 in the middle, 4, 8 over here, and 1 to 5, 3 over here. They call this one, I'm just write it up here, A, and this one B. So on part A, they ask you, what is the elements in A? So all I have to do is list the elements inside the A circle. So 1, I'm gonna put them in ascending order just because you don't have to. So there's A. Right, all the things inside the A circle. Okay, now part B says set of elements in A but not in B. All right, so, well, so look at the circle A. Notice how 6, 7, 9 is in both A and B, right? So we only want the stuff in A, but not B. So that would just be the 1, 5, and 3. So the set would be 1, 3, 5. That makes sense. Okay. C, part C says elements in U, but not in A. Okay, well, oh, I forgot there's some out here. I didn't notice that. C says set of elements in U, but not in A. So just look at the set A. So everything outside that circle would be the answer. So 4 and 8, 2 and 10. So not in A, but inside the box U. So 2, 4, 8, 10. Okay, part D. Any questions on A, B, or C so far? It's page 53 of the workbook. Part D, set of elements in both A and B. So basically what the ones they have in common, right? Which elements are both A and B, right? It's that slice in the middle. Set of elements in B, but not in A. Okay. Okay, so look at the picture on page 53, or the one I drew up here. So everything that's not in B, sorry, not in A, but inside B. So only the 4 and the 8 are outside of A and in B. So you would just say the 4 and the 8. Okay, last one. Set of elements in neither A nor B, meaning it's not inside A and not inside B. So the only two numbers that I see outside the circles is the set 2 and 10. The two elements 2 and 10, right? Look at the picture. Those are the only two numbers outside. Any questions on example 5? Yeah, let me give you some definitions, or I guess kind of like formulas, but first thing we need to know is, what does a union mean? Just in case you forgot. We use the symbol U like this, the set symbol. So visually, A union B means you have two sets and you're combining them together into one big set. So if the set is in here, right, the shaded part is the union. So basically the entire two sets together. That's what this means. A union B. Intersection is written this way, upside down U. So that means A intersect B is visualized this way. So if you have two circles overlapping each other, this intersection piece is what they mean. That is A intersect B, not this other, not the outside stuff. Okay, so the complement of A, written this way. In this book, they write it as in capital A with a little quote on it. So if you see that, that means complement. What does that mean? This is what it means visually. It basically means not A, everything outside of A. So if this is A, then A complement is everything out here. So not the A. Okay, that's what this means. Let me give you one more rule just in case. You guys okay on these first three definitions here? Okay, you turn the page then. Oh, right, let me give you that definition. Formula here, I guess we'll call it number 4. I believe it's called De Morgan's laws. So basically, if you have A intersect B and you do a complement, you switch them all. You put complement on both of these parts, but you switch the symbol to opposite. So the complement of A intersect B is A complement union B complement. Okay, now part B, the other way around is of course the opposite. That'll be A complement intersect B complement. So let's do an example now. Let's think of enough formulas for the rest of the section. So U is equal to the set of 0, 1, 2, 3, all the way till 9. A is equal to 1, 2, 5, 6, 8. B is equal to 0, 1, 5, 7, 8, 9. Okay. So part A says, what is a complement? So basically what you would say is what's not inside the A, but is everywhere else, right? Because U is 0 through 9. A is 1, 2, 5, 6, 8. So what is missing in here out of these? That would be not A.
Wouldn't it be 0? And I think that may be it.
Yeah, that'll be 0. What else? 3, right?
3, 7, and I think believe will be 9.
Yeah, 0, 3, 7, 9. Yeah, that's it. So that's not an A complement. What about B complement? What's not inside the B?
Wouldn't it be 2, 3, 4, and 6?
Yeah, that's it, right? You got it. What's inside A intersect B? Remember, intersect means what do they have in common? Where do they overlap? Look at the A and the B, right? They both have 1.
Maybe 1, 5, and 8.
Yeah, 1, 5, 8. That's right. That's what they have in common. Okay. Now, if you combine them together, union, without repeating anything, what is the new set if you combine these two together?
Wouldn't it be 0? What do you mean, like the numbers 0, 1 without doubling it?
Yeah, because if you double something in a set, it doesn't really, it's just the same element, doesn't count.
So 2, 5, 6, 7, 8, 9.
5, 6, yeah, 7, 8, 9. That's right. Does union and intersection make sense? Okay, next one. A intersect the empty set. Let's think about that. This is asking where an empty set has in common with the A set. So think about it this way. Remember how we said that every set has a subset of the empty set. But another way to think about it, I think an easier way to think about this is A is this set here, right? Does it have anything in common with an empty set? Right? This one's not empty, is it? There's stuff in there. So an empty set would be something like this. These have nothing in common, right?
No.
So you would say they have nothing in common. It's empty. See what I mean?
So if there's no empty spot, then if there's nothing in there, so it'll just be nothing.
Yeah, pretty much you can say whenever you intersect with an empty set, it will equal empty.
Okay.
Now, do it the other way. What if we said B union empty? So if I combine the B with something that is empty, do I add anything to the B?
No.
No, right? It's like I'm adding 0, so the B doesn't change, does it? It's still equal to B. So you would put B. So whenever you union with the empty, you get with what you get the same setback. Okay. Well, let's do some more. I guess I'll turn the page in just a second. All right, you guys good on this page? Let me know if you want me to wait on turning it. Let me open the window here. Right. Okay. So for number 7, U is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. One, 2, 5, 6, 8. B is 0, 1, 5, 7, 9. 0, 1, 5, 7, 9. 1, 2, 5, 6, 8. Okay. That looks like it's the same stuff. Whatever. Okay, so they ask us for part A. What is not in the union of A union B? So one way you can think about it is, what's not in the union, right? Because this complement means not this. So what you could do first is say, let me just find A union B first. So combine them together into one set. You're going to get 0, 1, 2, 5, 6, 8. Oops. Yeah, so that's the combination, right? A union B together gives me this. You guys agree? Did I miss anything? I don't have the answer, so I'm just doing it as I go. So let me know if you spot something. Okay. So what's not in here? That'll be this answer.
Be 3, 4. And I think that might be it.
That's it, right? So see how it helps to do these first? So let's do this one, just in case. What's the intersection going to be? What do they have in common?
1, 5. That's it.
All right, part B. My mouse go. There you go. Part B says, what is in the intersection of a complement of A intersected with the complement of B? So it helps to find these first, right? And then see what they have in common. So what is not inside A? What is not inside B? So not in here. And remember that U is everything through here, from here to here, right? A and B are inside the U, right? A and B are subsets of U. So don't forget. This is like, U is like your universe. A and B are like some planets inside there. Okay. So what's not in here? 3, right? Not inside A. 4. 7.
And 9.
9. 3, 4, 7, 9. Yeah, that looks good. Oh, forgot the 0 biscuits. I'll put it at the end, I guess. Okay, what's not in B? 2, 3, 4, 6, 8, right? Did I miss any? Okay, so now what do these two have in common, right? Because that's what this is asking, the intersection.
You said what was the question?
Yeah, what does these two sets have in common? The complements. That's
The three, it was be a 3, 4, and I think that might be it.
yeah. So that's what intersection means, what they have in common. So we found the complements. But remember earlier we said that if you do a complement of the whole thing, you end up getting this, right? If you turn back a page on the notes here, we said the De Morgan's law tells you these two are equal here. So if we remember that, we didn't have to do that work because these, we should have seen that these are the same by that formula. All right, so I'm gonna skip 8, it's the same type of stuff. So the number 9 is asking about cardinal numbers. So they're saying, let me show it to you. I'm going to shorten it up just to save writing space. A set A contains 95 elements. So the number of elements in A is 95. The number of elements in B is 84. They have 24 elements in common. So that means A intersect B is equal to 25. They're asking how many elements are in the union. Okay, so I'm going to shorten that up for you. So basically they're saying, so how many elements are in A union B? So the number of elements in A we said was 95. Number of elements in B is equal to 84. And then the number of elements in the intersection is 25. So there's a formula that says the number of elements in a union is equal to the number of elements in A plus the number of elements in B minus the overlap, the intersection. And you subtract one of these because if you think about it, right, if you're adding one circle plus the other circle, you're going to add that middle part 2 times. So you subtract the middle piece once. Does that make sense? So just plug in the numbers. 95 plus 84 minus 25. That will be Something, I don't know what that is. I got 153.
154.
Therefore,
Yes, sir. 154.
my bad.
You're close.
There we go. Any questions on number 9? So just use this formula here. I'm going to start for you. Example 10. So this will be the last one for section 5.3. You want to move on to something else. So in a survey of 200 registered voters, 96 people said that the economy is one of the top issues. 97 people said that national security was the top issue. 29 said that they were both one of the top issues. How many people in the survey thought that the economy or national security is one of the top issues? So basically, this or piece right here is telling you that that means a union. Okay. That's the hint. So I'm not going to write the whole paragraph. I'm just going to write the question. How many people in the survey thought that the economy or national security was one of the top issues? Okay, so that's the keyword right there. They want to know the number of elements in A or B, which means the number of elements in A union B. That's the real question. Let me switch back over here. And then we said the formula was going to be the number of elements in A plus the number of elements in B minus the intersection. So let's say that A is economy and B is national security. So this will equal the number of elements in the economy that they said people were interested in that. 96 people said that the economy is one of the top issues. So 96 plus 97 said that security was a top issue. So that's that one. And then 29 said that both were important. So that's the intersection. So the number in the economy, number of people who said economy was important, number of people who said national security was important, number who said both were important, intersection. So what is that going to be?
164.
164. That's it. So we're just using that formula again. Just to make sure you're able to identify what is what. So labeling it yourself will probably be a It's probably a good idea. Okay. Any questions on 5.3? Do you understand what union means? Do you understand what intersection means? Can you find, do you know what a complement means?
Yes, sir.
All right, so to 5.4. 5.4 is going to be same kind of stuff, except we have 3 sets instead of just 2. Let me show you. See how they give us a big U, and then they have A, B, C, and then they start combining stuff together. So let's do it. Let me write down all that information on the next page. So 5.4 is about set operations. Venn diagrams. With 3 sets. So example 1 gives us a bunch of stuff. So U is 0, 1, 2, 3, all the way till 11. A is equal to 2, 3, 5, 7, 11. B is 1, 3, 5, 7, 9. One, 2, 3, 5, 8 is C. So this is information that they're giving us. I think it'll help to find the unions and intersections of each one. So let's do the intersections first. So A intersect B. What do they have in common?
3, 5, and 7.
3, 5, 7. Okay, what about A intersect C?
2, 3, and 5.
Okay, and then B intersect C.
5 and 1. 1 and 5.
Yeah, 1.
Oh, 1, 3, and 5. My bad.
Yeah, there you go. Forgot that 3. Okay, so that's all the intersections. Now, A union B. They combine A and B together. Be 1, 2, 3, 5, 7, 9, 11, right? Did I miss any? I think that's good. A union C. All right, just go ahead and do all of them. That way, when they ask questions, we have everything ready. A union C. Combine them together. 1, 2, 3, 5, 7, 8, 11. Okay, now B union C is 1, 2, 3, 5, 7, 8, 9. 1, 2, 3, 5, 7, 8, 9. Okay, let's do complements. What's not inside A? We're getting all the possibilities right now.
Number 1, 4, 6, 8, 9, 10.
Yeah. B complement.
2, 4, 6, 8, 10, 11.
Yeah, 2, 4, 6, 8, 11, you said? Oh, wait, 10.
10, 11.
Okay, C complement.
4, 6, 7, 9, 10, 11. And actually on the other ones, it should be 0 too, because they don't have 0.
You're right. You're right. Just tack it on down there, I guess. That looks weird, but okay. All right. No, we did it. We did all everything we could have possibly thought of. Let's actually get to the questions. We're just screwing around at that point. The question says, what is C union A intersect B? So, but now that we have everything ready, these will be easier. So A and B are right here, right? 3, 5, 7. If you combine it with a U, with C, sorry, combine this guy here with the intersection, what are you going to get?
You said to combine out the bottom section.
Yeah, we're going to combine the C and the intersection. See it?
So when it be 1, 2, 3, 5, 7, 8.
Yeah, that's it. That's the answer, part A. See how it's easier once you got everything set up, right?
Yeah.
Part B, C union A intersecting C union B. So C union A is right here, right? It's backwards, but it's the same thing. You can write them either way and you'll get the same. So A union C is the same as C union A. So this guy, what does this one have in common with C union B? So these two right here, you see that? They're intersecting these two sets. So if you want to show more work, you could do this. C union A is this one. What does that have in common with this one? So that's what they're asking. You see that? So that'll simply be, I'll put it over here, I guess. They have in common 1, 2, 3, 5, 7, 8. 1, 2, 3, 5, 7, 8. That's it for part B. Part C says, well, first of all, does that make sense? Do you see how I got that? Okay, then let's move on to the next one. B union C complement. We didn't find that one, but we have the complements right here, right? So combine them together. That'll go in here. So A is right here. 2, 3, 5, 7, 11. Okay. Intersected with. Now combine the two complements together. So that'll be 0, 2, 4, 6, 7, 8, 9, 10, 11. So what do they have in common? Intersecting them means what they have in common. Two. Is that it?
Yeah.
7. 11. I think that's it, right? 2, no 3 in common, no 5 in common. So yeah, this will be it. So any questions on how we found this part? B complement union C complement. That's this part here. And then A is just A, that's given to us. Then we see what they have in common, which is the answer. That's it. Okay. Yes, cool in this example 1, 5.4. Yeah, example 2 is just wants us to construct the Venn diagram. So basically draw the picture. So we're almost out of time. So let's see if we can do 2 of these. So they give us U, 0, 1, 2, 3, all the way until 11. A is equal to 2, 3, 5, 7, 11. B is equal to 1, 3, 5, 7, 9. C is equal to 1, 2, 3, 5, 8. So this is given to us. So there's A. Here is B. Here is C. My drawing is not the greatest. So what do y'all have in common? We should start with that. All 3 of them. They all have 3, right? And 5. Yeah. So right in the middle will be 3 and 5. Now, what do A and B have in common? But that is not inside C. Looks like 7, right? A and B have 7 in common. I'm gonna zoom in a bit here. Okay, now what do B and C have in common? But it's not inside the A. Okay, that'll be this piece.
Three. They have 1, 3, and 5.
The 3 and 5 is inside the A, right? So we can't, those are already right there. You see that? So 1 is inside
1.
B and C, right? See how this right here represents what they have in common. Does that make sense?
Yeah.
So these 3 are in common with B and C, like you said, but only 1 is outside of the A here. Now look at this one. What is inside A and C, but not in the B?
2.
A and C looks like, yeah, 2. That's it, right?
Yeah.
Okay. Now, what is only in A but nothing else? That'll go here.
11.
11. That's it, right?
Yeah.
Okay, what is only in B but nothing else?
9.
What's only in C?
8.
Yeah. What's outside of all 3? In here somewhere.
0.
Yeah, 0's in none of them, but it's inside the U.
The 4.
4.
6. And 10, 11.
But 11's there, but 10's good.
Oh, 10. Yeah.
So this is all the elements. So these 4 are outside the circles and the rest are inside. So this is the visual for what's happening here, right? Now, A intersect, now the symbolically, right, with symbols. A intersect B intersect C, right? What they all have in common, we said was 3, 5, right? That was this one, visually. A intersect B, right, was this one that they have in common. But technically, it would be this whole piece. You see what I mean? Okay. B intersects C would be 1, 3, 5. A intersects C was 2, 3, 5. Does this make more sense when you have the visual?
Yes.
Okay. But if they would have told you what's in A and B, but not inside C, right? You would say 7. Because this is outside of C. Right, and then A union B would be both A and B together, but you only count the middle ones. So it'd be 1, 2, 3, 5, 7, 9, 11. Right, all these 2 circles together, A and B. I mean, they didn't ask for any of this, but I just want you to see how it's all there, right? All right. Well, we'll stop here. You guys have any questions on what a Venn diagram is? What union, intersection, and complements mean? Can you find them yourself? Can you create the pictures?
Yes, sir.
All right, because that'll be what's on your homework. So just give it a shot and let me know on Thursday. I can do some more. All right, guys.
Are we gonna be in class or are we gonna be on online?
I'll probably be in class, but I'll let you know the night before this time, because today was a little last minute. I apologize about that.
It's not a problem. All right. Well, we'll see you on Thursday.
All right. See you then.